Hi everybody, welcome to another video in Math 1324, section 3.2, compound and continuous compound interest. So we briefly introduced this in section 2.5. Now we study that in depth. Now let P be the principal or the present values. So pretty much the amount that we invested or borrow. And then the rate. This is every year as decimal, and it is compounded m times a year. And the future values or the amount h after t years. So t is the time in years. So we talk about that. In that case, I is equal to r over m, which is the rate per compounding period. So let's say if it is monthly, so that would be the rate for every month. And n is equal to mt will be the number of compounding periods. For example, if we borrow money to buy a car and we that to be paid off in 5 years, compounded monthly, so we have to pay it every month. So 5 years monthly, 12 times a year, 5 times 6, 5 times 12 is 60. So that gives us the total number of payments, or the total number of periods. We can write like this, but just focus on this for that form. Right, now if $1,000 is borrowed at 10% interest rate compounded annually, compute the interest and the amount for each year for the first 4 years. Right, so first when we have $1,000, so that years 0, or we start with 1,000. After 1 year, we have 10% of that, and now 10% of 10% is 0.1 times 1,000. So after 1 year, we have the interest. So I'm just going to write this interest is going to be $100, and originally is 1,000, so the amount going to be that interest. The amount will be 1,100, so 1,100. Right. Now this is after 1 year. Now after another year, this will multiply by 10%, right? Each time it is 10%. So 0.1. And so that gives us the interest now is, the interest only for this amount is 110. The amount then will be 110 plus that. $12, 10. But after that, the interest for year 1 and year 2, the total interest will be 100 for the first year. This together show the total interest. The total interest will be 10 and 10 after the first year and the second year. Now another year go by, that will generate 0.1 10% to whatever that year is. So that compound interest. So the interest is based on what we have on previous year. It's not from the first year. So interest just keep compounding like this. I get 0.1 to it. So we have this, and we times 0.1, and that would be 121. And we have that from the previous year plus the interest for this year. So we plus this two. That will be equal to 1,331. And the total interest will be 1, 2, and 3. So we take 210 plus 121, 331. Of course, that compared to the beginning. So the total interest 331. Now let's do it one more time. So it's after the first year, second year, third year. Now do one more time. Now the interest rate we apply to the previous year to get to the next, and that only gives us the interest. So we have that multiplied by 0.1. So 133.1. And the amount will be previous amount plus the interest for this on that year, 146. 1,464.1, and the total would be 400. So the total interest, of course, we just subtract this back, or we're going to add all the interest for every year. 464.1. So this is compound interest. It just the interest is based on the previous year, and then we have to add whatever the interest on the previous year as well. So this first year we calculate interest, and then plus what we have earlier, and then the next time we calculate interest on that year plus what we have earlier. Just keep compounding like that, and with that we generate more money. And the point here is because of the inflation, the values of money will decrease. So in that case we do this just to counter it, and so that's why it's a lot more popular in every banking institution to use the compound interest model. Right. Find the amount to which 1,500 will grow if it is compounded quarterly at that interest for 10 years. Now this is just straight up, just right now whatever we have, 1,500, that will be the principal. Compounded quarterly meaning 4 times a year. Interest rate for 10 years. And this asks for the amount, so the future values. So just start with the formula. So 1,500 1 plus the rate over 4 over 4 times 10, right? 1500, 1 plus 0.0675 divided by 4 to the power of 4 times 10, or you can just time 40, just say 40. So that 2,929.50 cents. Right, it'll be just like that. Now, computing the inflation rate. Suppose a house was worth 68,000 in 1987 and was worth that in 2004. Assume the constant rate of inflation from 1987 to 2004. What is in the inflation rate? So let's say we start with A equal to P1 plus R over M to the MT. So in this case, use M equal to 1, so we have that. Keep things simple. What we have is in 1987, so that is the original or the principal is 68,000. And then the future values 104. And we have M. We don't know R. But we know T, right? T is from 1987 to 2004. So T is the difference in those years. So that's 17 years. So it was 17 years. Now just substitute everything we have in the formula. 104, 68,000. M equal to 1. We still just keep that. Rate we don't know. M is 1. 1 times T we do know is 17 years. Right, now let's just simplify this a little bit. We have 104. We can just get rid of the 1,000 and just say 104 and 68. Now since M equal to 1, just say 1 plus R to the 17. Right, now we just solve for R. It's not that bad. What we do is we can divide by 68,000. Just try to get this term by itself. I just have 104 divided by 68. You have 1 point. Okay, I'm just going to write 1.529. 1 plus R to the 17. Now to get rid of the 17, what we do is we can take the root to the 17. On both sides. Right. So in this calculator, we have math. Go to option this, and we say 17, and when we highlight it, hit enter, that copy and paste. So we take the 17 root of that, and we have 1.0253 equal to 1 plus R, and subtract 1 on both sides, we have R, and that's what would be the rate. So the inflation rate of 2.53%, which is, I think, good. So once again, if we're trying to solve for the rate, we're going to take the root on both sides to cancel the power. Right. Roll time of an investment. How long will it take for the 5,000 to roll to 1,500 if the money is invested at 8.5 compounded quarterly? So let's write down what we have. 15. How long will it take? So we start with the question. T equal to what? We start with the principal of 5,000. It grows to 15,000. Invest 8.5%, so the rate is 8.5%. .85 and compounded quarterly. So we start with the formula. Put everything we know. Right, once again, usually for this problem, if we know the future values and the original amount, we just go ahead and divide 1 to simplify to get that term by itself. So divide by 5,000. That gives us 3. And we have 1 plus 0.085 divided by 4. And that to 40. Now we're trying to solve for t. This in section 2.6. If you want to solve for the exponent, you can take the ln on both sides. By the way, I'm just going to combine this. To the 40. So that gives us ln of 3 equal to 40 ln of 1.02125. And then we can divide by 4 on both sides and divide by ln of that on both sides. So t equal to ln of 3 over 4 ln of 1.02125. We have 13.06. So that's about 13 years. So take about that much to triple an amount. So that I think is not bad. Continuous compound interest. Now as m increase, we'll approach into different formulas now. is A equal P e to the RT, where E is 2.7, 1828, 1828 and so on. So P is still the principal, A is still the future values, and R is still the rate, and T. So pretty much all the variable still have the same meaning. Look at this example. What amount will an account have after 10 years if 1500 invested at the rate compounded continuously? So we have 1500, that is what invested, so that the principal after 10 years. And the rate. And everything. And ask what amount will be. So that pretty much asking for the future values. So A equal to P E R T. Principal of 1500. E the rate times 10. Times 10, we just move to decimal place 1 to the right. Or just put all of them on the calculator, it doesn't matter. 1500 times e to the 0.675. So we have 2946.0. We should enter everything in pennies, so up to 2 decimal places. Right, so it's straightforward. Now what's not straightforward is the next one. How long does it take for investment to double its values if it is invested at 7% interest compounded continuously? So what do we have? So first, how long does it take? So asking for time. To double the values. So meaning that the future values is twice the principal. What we have in the future will be twice what we have now. So have that. And 7% compounded continuously. So A equal to P E R T. So A is equal to 2P. P is still P. E the rate 0.07 times T. Just like what we have, if we have A and P, the first thing we do is just divide by the principal, so that cancel out, and we just have that term by itself. Next week we'll take the ln on both sides. So we have ln of 2 equal to 0.07t ln of e, and ln of e is equal to 1. So we have ln of 2 is 0.07t divided by 0.7 on both sides. And we have 9.9 years, so that's about 10 years. So about 10 years. Right, now what we have is the rule 70, and let's spell it out. The rule is the time it takes for an investment to double its balance is approximately 70 divided by the rate as percent. So for example, on the previous problem we have 7%, and we take 70 divided by 7, that's 10 years. So that's pretty good approximation, right? So consider the previous example where the rate is 7%. Again, we're going to take 70 divided by the 7, not the percent, just the 7. That's about 10 years. 10 years. So the time it takes for double investment at this condition is about 10 years. So where did we have that rule for? Well, let's go back to this. We have ln of 2 divided by 0.07. ln of 2, if we put that in the calculator, that it was 0.693. And 0.07. Now notice we divide by 7, not 0.07. So we can time 100 top and bottom. So you have 69.3 over 7. So that pretty much, this is approximately equal to 70 over 7. Then of course we should say that is the rule of 69.3. But it doesn't have the nice ring to it. So I said round that to 70. Therefore we have the rule of 70. Right. Annual percentage yield. The simple interest rate that produces the same amount as the given compound interest rate in 1 year is called the annual percentage yield, APY, or effective rate. Right. So the simple interest rate so we start with this. So A equal P times 1 I did say that it is in 1 year, so T equal to 1. So we have A is equal to P 1 plus R over M times 1, because T is equal to 1, right? So that is the future values. If we just want the interest, remember in general at any event the interest is actually equal to the future values minus the principal, right? What we have in the future minus what we have now, is that will be the interest. So we take a minus this. So sorry, that will be a. Just start over. A is P 1 plus R over M to the M minus P. So that will be interest. Now the simple interest rate. The simple interest is I equal to P I equal to PRT. So we're going to black PRT equal to this, and this R of course different than that R. This R is what we're trying to find, so this actually R here, let's say that capital R. Capital R here is equal to the interest rate, that is the annual percentage yield, is the rate of the simple interest. That would have the same effect as this. So we let each of this interest equal each other, and we actually factor out the P. And then we divide by P, and T is equal to 1, right? So PR is equal to that, and divide by P on both sides. And we arrive to the formula, the R here, or we should say it APY is equal to, that cancel out, 1 plus R over M to the M minus 1. So next, I'll find the annual percentage yield for a credit card that has the interest rate of that compounded daily. So the rate is 18%, but that's for the whole year. If it is 18% daily every day, that would be extremely high. Daily, so it will be 365 times, and that's all we need. We have an R and we have an M. Of course the R here should write that as decimal, so the APY so 1 plus 0.18 over 365 to 365 minus 1. Oh, sorry, I typed that wrong. Should be this. And so I have 0.197. So that is about 19.7%. So because it's a compounded daily, so the effect of daily make this interest rate actual is about 19.7. If it is interest, simple interest, meaning that for the whole year, if not make any payment, that's going to go from $1 to 19 cents, or almost 20 cents interest for every dollar for the first year, right? So the effect of daily have massive effect, make that more than the 18 advertised. Right. Before we finish section, let's have the note on the calculator. So just take a look at some of the problem. So in the calculator, I'll write out what we need. So if on this calculator TI-84, we need apps, and we go to finance, use the app finance, and then we go to TVM solver. So pretty much we hit enter a few times. So let's do that again. Apps 1, 2, okay, hit 2 times. Right. Now I need n. Now the confusion part is this n is not different than the n here is the number of payments period or the number of periods. The I is the interest. This is not the I, it's in the formula, this is the interest rate. So this is equivalent to the R in our formula. PV obviously present values, payment. In this case we have that 0 and future values, and then here that's equal to n, how many times it is compounded a year. Right, and this case we fix this. One note in the calculator is whatever we give or our pocket is negative, into our pocket that positive. So let's look at one problem. So here is the problem. How long will it take for that to grow to 15 if it is compounded quarterly? Right, so let's start with n. We don't know, so we leave that blank. The interest rate 8.5. Just going to enter 8.5, not percent. Present values we have 5,000 to growth. Let's say we're going to invest 5,000. So out of our pocket we give 5,000 or deposit to the bank, and we don't make any payments. In the future we're going to get 15,000 back. So we minus 5,000 out of the pocket and then get back 15,000 in the future, and this is compounded quarterly. Right, so whatever we're trying to solve for, we'll leave that 0 for a moment. And now when we're trying to solve for anything, hit alpha and enter. As you see this solve here, so alpha and then enter. We have 52. There's 52, and it is so 52 payments or 52 periods, and it is 4 times a year. So if you divide by 4, we have about 13.06 years. Right, so that works. And look at another one. This one. For 17 years times 1 payment a year. The interest rate, don't know, just put 0 at the moment. Present values, let's say we buy the house and then we sell it back. I mean, we sell a house. Sorry, we have to pause first. So to buy the house, we have to give the money, and when we sell it back, we get back that, and it is 1 time a year. Now we're trying to solve for the rate, so alpha solve, and we have the rate. Right. Does it work every time? Now let's look at the last example using the calculator. So in this case, it is 10 years, 4 times a year. interest rate 6.75, and the amount to growth, let's say again, is investment, so we out of pocket, no payments. Future values we don't know, but we know that it is compounded 4 times a year. Alright, now we solve for the future values, alpha, solve, and that's exactly what we have. Right, so of course we can use the calculator or we just use the formula. It's not as bad. The annual percentage yield though, we have to calculate ourselves. Right, so with that we finish section 3.2. As always, thank you for watching and see you in another video in Math 1324.